Okay, good morning, ladies and gentlemen. Welcome to our first lesson. So some of you guys will be getting this in person from me. Some of you guys will be getting this remotely, and if you're watching this, you're probably one of those people that will be getting this remotely. As we talked about in the video about the student contract, the expectation is the same, whether you're in school or remote, that we're going to be following along. We're going to be taking notes, whatever I'm writing, you're writing. Again, we will have notebook checks every week on Friday, so make sure that you've got those notes so that we can submit them every Friday. And we should be good to go, I think. So we're going to start kind of from the beginning. We're going to spend a little time reviewing some of our 6th and 7th grade topics before we really jump into the 8th grade stuff. So lesson for today, which we will continue with a little bit tomorrow, is turning verbal phrases, right? So something like, the sum or the difference or product or quotient of expressions into algebraic expressions, so into numbers and letters when we use variables. So let's just review maybe one-step equation. So we're going to spend a full period doing what I have here on the do now. So obviously we haven't done it because we haven't done anything yet. This is something you should remember, though, from really 7th grade, from 6th grade as well. So as a little icebreaker here, right, so we need to isolate our x. So we want to eliminate the 12 by adding its opposite on both sides. Right, so for our first one, we'd have x is equal to negative 17. And if we check it, and we will talk, of course, in detail when we get to that point about what it is to check an equation. Negative 17 plus 12 is negative 5. And for the second one, we want to eliminate that 15. So we add its opposite on both sides. I should have added that here. So I get x is negative 9. Because 15 plus negative 9 gets us positive 6. I'm not going to go through the last one because I want to save that actually for when we do the lesson, when we get to one-step equations. But if you want to work it out on your own, you should end up with x is equal to negative 14 because negative x is the opposite of x. So the opposite of negative 14 is 14 minus 11 is 3. But again, that's something we'll hold off on for a few days from now, really from next week. All right, so translating verbal phrases. So what I have on the left is each of our verbal phrases. What we're going to fill in on the right is our algebraic expressions. So this is what I expect to be in your notes, okay? So if you're watching, obviously you are watching the video, right? Those of us getting it in class, the flow is going to be a little bit different, but the content is exactly the same. You're going to write down the verbal phrase, and as we fill it in, you're going to write down the variable expression on the right. So we're going to look for words that are going to imply specific mathematical operations. So in the first one, we have what I'm hoping is a pretty obvious one, which is the word sum, okay, which implies addition. We have a number, which is any variable, so I'm going to stick with x. So if you want to use n or p or q or your initial or whatever, that's fine. So the sum of a number and 9 is going to be x plus 9. Okay, could we put 9 plus x? Of course, right? We know the commutative property of addition says we can add or multiply in any order. But as far as what's maybe more correct, we're going to stick with the order of the term. So the sum of a number and 9 should be x plus 9. Now for the second one, the difference, right? Now we can't write this in any order, right? 5 minus 3 and 3 minus 5 are not the same. They're opposites. And that will always be the case. If you take two numbers and subtract them in different orders, you're always going to get opposite results. And we'll talk about that algebraically closer to the end of the year. So the difference of a number and 21. So I'm going to use, let's use n this time, right, just to do something different. Difference, hopefully we know, is subtraction. The difference of a number and 21. So it doesn't matter what variable you use. All right, and I'll probably say this a lot, guys. And I tend to do this, I don't think I'm doing this yet, but I tend to sometimes go a little bit fast. Well, that's the purpose of the video, right? You pause it, you take notes, you go back, you rewatch certain things if you need to, you take those notes. So don't feel like you have to keep up with me if I'm going a little too fast for you. The next one, we've got product, which hopefully we know that that's going to be multiplication. So when I do this lesson in class, I always have students that will say 6 times x. And I'll say, okay, what's another way? And then someone else will say, well, for multiplication, we can also use parentheses. And I say, sure, both of those are perfectly acceptable, but really that's not the most streamlined way. That's not the simplest way, right? The most efficient way. So that's a word I'm going to use a lot during the year, where we can do things in multiple ways. We're looking for the most efficient way. So the product of 6 and a number, we can say 6x, okay? When algebra was developed, it was understood, or mathematicians came to an understanding that, hey, we don't want to have multiplication symbols like the x because we're going to be using the variable x, and we don't want to be using the multiplication dot because it looks like a decimal. And we could use parentheses, but if you're multiplying a whole bunch of numbers, you got an awful lot of parentheses. We're just going to put the number 6, which is what's called our coefficient, next to our variable. And when we have a coefficient next to a variable, the implication is that there's multiplication there. The next one has a quotient, so the quotient of 48 and a number is going to be 48 divided by x. And again, for the difference in the quotient, it is important that we have the order correct. X divided by 48 would be the quotient of a number and 48, which those are reciprocals. They are very different. And let's take a look at the last one. So 1/5 of a number. We can do this in a lot of different ways. So the most basic way is I can say 1/5, let's say x. Now what are we doing if we're multiplying by 1/5? Well, we're multiplying by 1 and we're dividing by 5, which is the same as just dividing by 5. If I think about 1/5 of something, like 1/5 of 100, 1/5 of 100 is 20 because it's 100 divided by 5. So another way we can say 1/5 of something is that thing divided by 5. We can also use the decimal representation of 1/5, which is 2/10. So we have 3 different ways, potentially I guess more, depending, you could say 20 hundredths or something like that, but 3 pretty efficient ways of saying 1/5 of a number that are, visually at least distinctly different, though mathematically they're all the same. All right, let's take a look at some that have multiple operations, right? So the first one says 4 more than 8 times a number. So we're going to do this in pieces, right? We're going to say, well, how would I say 8 times a number? Well, 8 times a number is 8x. How would I say 4 more than that? Well, the word more implies to me I'm going to be using addition. So I need to take whatever 8x is, and how do I take 4 more than that? I'm going to add 4 to it. So that should be the expression 8x plus 4. All right, the next one says 3 times a number. I don't know why it says a number twice. 3 times a number increased by 15. So we're going to say, okay, let's do 3 times a number. And after we've done that, let's increase it by 15. So 3 times a number is 3x. And then we have to increase that by 15. Now let's think about a common mistake that I see here. This is not 3 times the number, comma, increased by 15. This is 3 times the sum of a number and 15, which we will see at some point, maybe tomorrow. But that's very, very different because if I distribute the 3, I get 3x plus 45 instead of 3x plus 15. All right, now this is one that we start learning about this in 5th grade. And then our teachers in 6th grade will hammer this home. And in 7th grade, and by 8th grade, some students, 9th grade even, some students still have trouble with this, right? 4 less than a number. So what I tend to do, what I did when I was younger with something like this is I'd make it numerical. I'd say, what's 4 less than 10? And I'd say, well, 4 less than 10 is obviously 6. And I would say then, well, how did I get the 6? Did I do 4 minus 10 or did I do 10 minus 4? And obviously I did 10 minus 4. Now, what is the point of this? The point of this is to say that when you've got less than a number, and this is what I've got here in pink, you have to switch the order of the terms, right? So in other words, if I want 4 less than a number and I'm calling that number x, we have to do x minus 4, right? And this will be assigned to me, whether or not you really paid attention and watched the lesson. If you're putting on your homework 4 minus x, I know you didn't watch the lesson, or I know you didn't get it, let's say, or I know you didn't take some notes. So really important here, right? Star this in your notes that when you've got less than a number, right, 4 less than something, we're taking 4 away from something, meaning we're subtracting it, meaning the minus 4 goes at the end. We're not taking x away from 4. Now let's extend that same concept on to number 4. 4 less than 3 times a number. So this is exactly the same, except we're not taking 4 away from x, we're taking 4 away from 3 times x. So that really should be 3x minus 4, right? I want to take 4 less than whatever this thing is. So whatever this thing is, I'm going to subtract 4 from it, so it becomes 3x minus 4. The next one says 5 more than twice a number, right? So what does twice mean? Well, I always ask the same simple question. If something happens twice, what does it mean? And someone will say, well, it happens 2 times. So twice means 2 times a number, and I want 5 more than that, okay? So I need to add 5 to it, so that shouldn't be so hard. Right, so 6 is where we're going to kind of throw back to what I talked about with number 2. With what was a mistake for number 2 is now not going to be a mistake. So let's see what that's going to look like. 7 times the sum of 3 and a number. So what we have to do is we're going to say, well, what am I multiplying 7 times? Right, I'm multiplying 7 times the sum of 3 and a number. So how do I say the sum of 3 and a number? Well, I can say x plus 3 or 3 plus x. So I want 7 groups of that. I want 7 times whatever that quantity turns out to be when I know what x is. So now I need to use parentheses. So if you see 7 times the sum, 7 times the difference, even technically 7 times the product, though there we won't need the parentheses, but we'll talk about that. You're going to need to use parentheses because you're multiplying a number times a quantity, right? And when we say the expression the quantity, that implies something that's in parentheses. So 7 times the sum of 3 in a number, we have to break out the sum of 3 in a number as x plus 3 and then multiply it by 7. And let's talk about half a number. So think about what we did with a fifth, right? So obviously the most basic way is just to say it's half of x. We can say when you take half of something, you divide it by 2. So we can say x divided by 2. And we can also think about the decimal representation, which is 5/10. So 3 different ways that we can do it, right? We can say half of x. We can say x halves, or x divided by 2. And we can also say 5/10 x, because 5/10 is the decimal representation of 1/2. All right, so this is a little bit harder, okay? So this is something you should have done in 7th grade. I'm not sure whether all of you did it or not. It's okay. Either way, like I said, I'm gonna try to review pretty much everything from 7th grade, at least in context of our 8th grade lessons. So we've got 25% more than a number, right? So when I think of a number, right, if I've got something, right, I've got this stylus in my hand, I've got all of it, right? And I usually hold it up, and I am, but you can't see it. But take your pencil, whatever it is you're holding, your notebook, and say, what percent of this pencil, let's say, do I have, right? You've got all of it. You have all 100% of it. Now, what if you had 25% more pencil than what you have? Well, if you've got 100% of your pencil and someone gives you 25% of a pencil, now you have 125% of it. Now, we don't put a percent sign in a variable expression. We have to use fractions or decimals. So I'm going to stick with decimals. So if I have 125%, to convert that to a decimal, we divide it by 100, which is 1 in 25 hundredths. So as a general guideline here, guys, well, let's do the second one and then we'll talk about it. I don't want to give it away. Now it says we have 10% less than a number. So again, right, you got that pencil in your hand. You currently have all of that pencil. You have 100% of your pencil. But now you lose 10% of it, right? You don't have the full 100% of it. You've got 10% less. So what percent of it do you have? You only have 90% of it. So if I've got 90% as a decimal, that's 9/10. So as a general guideline with these percent problems, and these are not, in the grand scheme of things, supremely important. We generally don't see this on the Regents. We see it very rarely on the state test. But it's something we should be able to do, and it ties in very nicely with our lesson. If it's more than a number, you're going to add that percent to 100%. And if it's less than a number, you're going to subtract that percent from 100%. So let's go to the next one. And these we have to be careful with the single-digit percents. So 7% more, right? I'm going to go back to I've got all of this pencil. Somebody gives me 7% of a pencil. Now I've got 107% of that pencil. Now what happens when I turn this into a decimal, right? It is 1 in 700ths x. All right, left to our own devices, some of us are going to put 1.7, right? Now what is 1.7? It's 170%, and that's not what they're asking us to do. All right, and let's think about the last one, right? It says 2% less than a number. Okay, so I have my whole pencil. I just lose 2% of it. I still have almost all of it. I've still got 98% of that pencil. And again, to turn a percent into a decimal, since a percent is out of 100, we divide by 100, and that's going to give us 98/100ths x. All right, guys, so this is your homework. And again, this is whether you're, live or remote. So the kids that are in class are going to be doing this. If you were in class and we did not get to the homework slide, then this is what you're going to be using, same way you would in class. Those of you doing this at home remotely, this is your homework. So what I want you to do is I want your paper to look exactly like this, okay? You're going to put the verbal phrase, right? You're going to write out the sum of twice a number n to -15. And then you're going to give me the variable expression on the right. I'm only giving you guys 6 problems. This should take maybe 5 minutes, right? Maybe 10 minutes if you want to stretch it and you go back to your notes, which you really should. But everything here has been modeled in the notes, right? You're not going to see something and say, wow, we've never seen this before. If you have notes and you go back to the video, every single problem here is almost exact. I mean, obviously I changed the numbers around, but I'm going to do my best this year, since we don't have textbooks and things like that, to have the homework on the slides and be really perfectly modeled to the lessons the best as possible. Questions, concerns, right? Google Classroom is the best place to do it. I'll probably say that about every day. If you want to send me an email, that's good too. But really the best place is on Google Classroom under the assignment to ask questions, or it's even better if you submit what you have, and then you show me and you say, hey, I had a question about number 3, and you show me your best attempt to do it, and then I can help you with it that way.